Hello guys, today we are reading about aldehydes and ketones. So before reading about aldehydes and ketones, we have to know where they came from. So it is the part of carbonyl group. What is carbonyl groups? Carbonyl groups are the species which contain C double bond O. In aldehyde, if we add H to the carbonyl group, it will make CHO, and CHO is the main formula of aldehydes. And in ketone, if we add R group, then it will become ketone. Aldehyde have CHO in their structure and ketones have COR in the structure. There is different type of aldehydes and ketones. Aliphatic aldehydes and ketones. When CHO or COR is present on alkyl group, it is known as aliphatic aldehyde or ketone. Aromatic aldehyde or ketone. When CHO or COR is attached to benzene group, then it is known as aromatic aldehydes or ketone. Next is symmetrical or simple aldehydes or ketones. Species in which same group are present around CHO and COR is known as simple or symmetrical aldehydes and ketones. Next is mixed or asymmetrical aldehydes and ketones. Species in which different groups are present around CHO and COR is known as mixed unsymmetrical aldehydes and ketones. Now next is dialkyl ketone. Dialkyl ketone is a species in which two same alkyl groups are present around COR group. It does not possess aldehyde, only ketone. Next is alkyl aryl ketones. Species in which one alkyl and one aryl group is present in COR group. Next is diaryl ketones. Species in which two same or different aryl groups is present is known as diaryl ketones. Now next is application of aldehydes or ketones. Methanol or formaldehyde, which we say, if we take 30 to 40% of methanol solution, it will make a formalin which is used for preservation of specimen in labs. Next is acetone. Acetone is used in nail polish remover, paint remover. Now next is naming. Naming can be discussed later. Now we will come to the topic of isomerism. Isomerism, there is different type of isomerism in this. First is position isomerism, when there is difference in position, like pen-2,1 and pen-3,1 are the example where molecular formula are same but position is different. Second is functional isomerism. In functional isomerism, the functional group changes, like pen-2,1 and pen-1-al. In one of them there is ketone group and another is aldehyde, but molecular formula is same. Now third is chain isomerism. Chain isomerism in which chain is different. Examples are pentane 2-on and 3-methyl butane 2-on. The chain is different. One is attached by mid and one attached linearly. And molecular formula remains same, C5H10O in all of the threes. Now fourth is metamerism. Arrangement of carbon atom around functional group is different. Example, pentane 2-on and pentane 3-on. Molecular formula is C5H10O. Now tautomerism. What is tautomerism? When arrangement of electrons along shifting of atom, mostly it will be H atom. So it is known as tautomerism. We do keto-enol tautomerism in this. Now next is dipole moment. Due to increase in electronegativity difference between C and O atom, the carbonyl group is polar in nature, so aldehydes and ketone has higher value of dipole moment. So aldehyde and ketone will have higher value of dipole moment. Now next is boiling and melting point. They have polar carbonyl group and thus there is strong dipole-dipole force of attraction between aldehydes and ketone molecules. Thus more heat is required to break the strong dipole-dipole force of attraction. So they have high boiling point and melting point. Solubility. Lower aldehyde ketones have carbonyl group can form H bond with water molecules. So lower member of aldehyde ketone are soluble in water. Higher member are not soluble. Alcohol require more heat to break, so boiling point increases as H bonding increases. The H bonding has greater than carbonyl bonding. Now there is a question, Why alpha hydrogen are acidic in nature in aldehyde and ketone? So what is alpha hydrogen? Alpha hydrogen are the hydrogen which is present on the carbon attached to the carbon which has carbonyl group. So after the removal of alpha hydrogen as H plus ion, the carbon anion is formed, which get stabilized due to dispersal of negative charge over oxygen atom of carbonyl group by resonance. Hence they are acidic in nature. Next question is why aldehyde and ketone are chemically active? Why they are chemically active? The carbonyl bond contains reactive pi bond, that's why. And second, due to high electronegativity difference between C and O atom, there occur a separation of charge, and carbonyl group is polar in nature. That's why. So that's all for today. Thanks for watching.